Welcome back, everybody. Today we're going to talk about solving rational equations that look a little bit different than some of the other ones that we've done. A rational equation, this is your first set of blanks, is an equation that has a rational expression for one or more terms. To solve a rational equation, multiply each side by the least common denominator of the terms of the equation. So that least common denominator is the last part of your sets. The last part we're going to add on here. If I have, we have to find domain restrictions. Which, a refresher, we use only the denominator equal to 0. Those are how we find our excluded values or extraneous solutions. Excluded values, extraneous solutions, basically what it means is we've done our job the right way, we've solved everything correctly, we came to these answers, but when we take a look at what we have and we look at what makes our equation undefined because the denominator is 0, then we can't have that answer, and it's called excluded or extraneous. Sometimes that means we end up with no solution. Sometimes it means if we had 2 or solutions or 3 solutions that we only have 1 or 2 instead. So let's try this very first one. We have our equation, it's equal to x. My first step is going to be to take this x and put it over 1. If we wanted to make these fractions all have common denominators, then we would need a 3 because of this 3 here, and an x minus 1 because of this. Multiplying by 1 doesn't really change anything, so we don't have to worry about any of that. So what this means is we're taking each part, there's 1, 2, 3 fractions there, and we're multiplying it by that common denominator of 3 times x minus 1. So 3 times x minus 1 over 1. So there's that one. Here's our subtraction. Our common denominator times the 2x over x minus 1. Here's our equal sign. And then we have our x over 1 times 3 times x minus 1 over 1. So we have this exact same value. Oops. Here, here, and here. Okay, we multiplied by that value. The reason why we do that is because when we're multiplying fractions, so I'm looking at this, and this as 3 separate pieces. When we're multiplying fractions, we can cross reduce. And so if I look top to bottom here, we can cross out this 3. That leaves us with x minus 1 times 3x minus 1. You would go ahead and FOIL or distribute or however you love to multiply this. And we get 3x squared minus 4x plus 1. I'm keeping that subtraction. In this next set, looking from top to bottom, what can we cross out? Oh, I can cross out the x minus 1s. Those reduce out, and I'm left with 3 times 2x. Well, 3 times 2x is 6x. Bring down that equal sign. I don't have anything in my denominators here, so I can't do any reducing. That means that I'm multiplying x times 3, which is 3x. And then we take that 3x times the x minus 1 that's there. So that's 3x squared minus 3x. I'm going to combine like terms over on this left side. That's going to be the negative 4x minus the 6x. That gives us 3x squared minus 10x plus 1 on the left equals 3x squared minus 3x on the right. Let's combine like terms now across the equal sign. I'm going to move my x squares together. The opposite of a positive is a negative. These both end up adding to 0. So we have negative 10x plus 1 is equal to negative 3x. Don't forget the negative from there. I'm going to bring my 10x over with the 3x by adding. 1 is equal to 7x. Divide both by 7, and we get x is equal to 1/7. Now, before I can say that's my answer, we have to go back to our original problem and find our excluded values. So I'm going to erase all this stuff over here. Remember, we can only have excluded values or restrictions from the denominators that have a variable. And so as I'm looking at what we have here, 3 does not have a variable, so I don't have to worry about that. This x doesn't have a denominator, so there's no variable there to worry about. That means our only restriction is coming from that x minus 1. And so we set x minus 1 is equal to 0, add 1 to both sides. And this says x cannot equal 1. Well, x cannot equal 1, but our answer is 1/7, and they're not the same. So this is a good solution. Our second example, I'm again going to start with putting this last 1 over 1 and asking, okay, what would our common denominator be? What do we have in our denominators? We have x minus 2, and we have x minus 2, and we have a 1. So it looks like our common denominator would be x minus 2. So we are multiplying x minus 2 by all 3 parts. And we have this plus. And again, the purpose for doing this is we can't solve for x if it's in the denominator. And I want to definitely make sure I solve for x. So I can cross reduce top to bottom. Those x minus 2's reduce out, and we have x. Bring down that equal sign. The middle, the x minus 2's reduce out. We're left with 2. Bring down that plus sign. We don't have anything to reduce in this last one, so we're just going to distribute the 2 by the x minus 2. 2 times x is 2x. 2 times negative 2 is negative 4. Work on combining like terms. I'm going to start with the 2 and the negative 4. 2 minus 4 is negative 2. I'm going to bring the 2x over with its x-like term. 1x minus 2x is negative x. Don't forget that negative with the 2. Divide by negative 1, and positive x is equal to positive 2. So right now it looks like our solution is going to be x is equal to 2. Let's take a look at our restrictions. Our denominator is x minus 2, and they're the same, so I only need to solve it once. And I want x minus 2 to not be equal to 0. So I'm going to add 2 to both sides. And we say x cannot equal 2. X cannot equal 2, but my answer was 2. So 2 is an excluded value or extraneous, and this has no solution. I know, we just did all that work for no solution. Let's try on the back side. One thing I want you to note over here on the back at the top is that you may, let's see if I can write a little bit better than that. You may need to factor. To find your common denominator or least common multiple. And so as I'm looking at our denominators, we have x minus 2, we have x. Yeah, this one over here, x squared minus 2x, I need to factor. And that's going to be pulling out a greatest common factor of x, and we're left with x minus 2. So I see x minus 2 and x. So it looks like x times x minus 2 will be our common denominator. So I take x times x minus 2 over 1 times the 3x plus 2 over x minus 2. Bring down that plus. In the middle here, x times x minus 2 over 1 times 1 over x equals negative 2 over x times x minus 2. I'm going to write the factored form for that. Times x times x minus 2 over 1. So again, we're checking to see if we can cross-reduce anything in each one of these individual chunks. Over on the left side, x minus 2's can reduce out. So I'm distributing the x to the 3, x and 2. X times 3x is 3x squared. X times 2 is 2x. Bring down that addition sign. In the middle, our x's can cross-reduce, so I'm distributing the 1 to the x minus 2. 1 times x is x. 1 times negative 2 is negative 2. Bring down our equal sign. And then over on the far right, all of this cross-reduces out. And so we are just left with that -2. All right, now we're going to clean this stuff up. I'm going to take care of my like terms over here on the left side in the middle. That gives us 3x squared plus 3x minus 2 is equal to -2. I see 3x squared and the x in the number, and I'm thinking I'm probably going to be factoring. Oh, I've missed factoring. Okay, so I'm going to add the 2 to the other side to get it equal to 0 because we are solving a quadratic. We have 3x squared plus 3x. These add to 0 and these add to 0. Well, okay. Take out our greatest common factor then, because remember, whenever we solve by factoring, we start with a GCF. Our greatest common factor is 3x. That leaves us with x plus 1. Well, I don't have any other factoring to do. That means that we can start solving. We set every x equal to 0. I solve for x here by dividing by 3 on both sides, and we get x is equal to 0. I solve for x here by subtracting 1 from both sides, and I get x is equal to -1. So right now our solutions are 0 and -1. But remember, we have to check our restrictions. And our restrictions come from our denominators. And remember, this was x times x minus 2. So we have x and x minus 2 that are giving us our restrictions. This top one, x cannot equal 0. That's already solved. We can't do anything more about that. Bottom one, we're going to add 2 to get x alone, and we get x cannot be -2. Well, our solution of 0 matches our restriction of 0 or our excluded value. So this is extraneous. We're not allowed to have it. But the -1 checks out because it doesn't match anything. So our only solution is x is equal to -1. All right, last one. I'm looking at the denominators and I'm seeing x minus 1, x plus 1. Oh, this last one we have to factor. These are both perfect squares in subtraction, so we're factoring by difference of squares formula, which is x minus 1 and x plus 1. So if I look at absolutely everything we have in our denominators, our common denominator would be x minus 1 and x plus 1 that we're going to multiply every part by. So starting on the left, we have x minus 1, x plus 1 over 1 times. This left side is -4x over x minus 1. Bring down your plus. Take our common denominator, and that middle term is 4 over x plus 1 equals x minus 1, x plus 1 over 1 times -8 over, and I'm going to write that in its factored form here. So there's our 3 parts. Let's see, cross-reducing. We can cross-reduce x minus 1 here, x plus 1 here, and everything top to bottom over there cross-reduces, leaving us with the -8. So to write what we have, -4x times x is negative 4x squared. Negative 4x times 1 is negative 4x plus 4 times x is 4x. 4 times negative 1 is negative 4 equals negative 8. These are my like terms. Let me erase and get some space over here. For combining those like terms, and we have negative 4x squared. These add to 0. Minus 4 is equal to negative 8. I see the x squared, so of course we're probably going to have to factor at some point here. I'm going to bring over that 8 by adding negative 4x squared. Negative 4 plus 8 is positive 4, and that equals 0. Always, always, always making sure that we're starting with a greatest common factor, and our common factor here is 4. Now remember, we really don't want our x squared to start with a negative if we can help it. So I'm actually going to pull out negative 4. That's going to make that a positive x squared and a negative 1. Factor the x squared minus 1. We have x plus 1 and x minus 1. We can't set negative 4 equal to 0. It doesn't work. It's not equal. So our only variables to solve for are these two. So we get x is equal to negative 1 and x is equal to positive 1. Now that we have our solutions, we go back to our original problem and we say, what are the restrictions of our problem? And so our denominators here are x plus 1 and x minus 1 from these common terms in our denominator. This x plus 1, we subtract 1, so x can't be negative 1. The x minus 1, we add 1 to get x alone, and x can't be positive 1. Well, this one matches this, and this one matches this, so when our excluded values match the answers that we get, they're extraneous. We are not allowed to have them. And since we lost both of the answers that we got, this one has no solution. Thank you so much for joining me today. Have a great rest of your evening. See you soon.